All right, the last time we were talking, I was mentioning the Roche limit, which has to do with the size of the rings. Okay, so the rings are made mostly of icy material. Um, this idea of the Roche limit is has to do with tidal forces, and Roche was a French mathematician who came up with this formula. Well, we're not going to deal with the formula, but basically tells you how close an object can be to its parent, um, to its the planet that it's or whatever object it's orbiting. Right. So in this case, it would be like a little moon or something like that. Um, as that moon gets closer and closer to Saturn, what happens, of course, is the same thing with the Earth's tidal forces. The tidal force just means that the force of gravity, in this case, it would be the force of gravity from Saturn on the moon, is pulling harder on one side than the other. And so what that does, what the Roche limit talks about, is how close the moon can be before the tidal force will simply rip the moon apart, right? So the rings of Saturn are within the Roche limit, and again they're made of ice, this icy material, um, and in fact that's why they're easily seen from Earth. All four outer planets, the gas giants, all four of them have a ring system, but they're really hard to see. You need either to be in a spacecraft that gets close to the planets, or a very very large telescope. One of the professional telescopes on top of mountains that they build. At any rate, the rings of Saturn are very easy, just even with a pair of binoculars, you can see them. I mean, you can't see them like in this kind of detail, but a relatively small telescope, you can, like what I call a backyard telescope, you can easily see the rings. And this gap right here in the rings is called the Cassini division. And if you can see that with your telescope, that's a pretty, that's a decent sized telescope. Um, all right. At any rate, so what else do we have to say about Saturn? Of course, it has a system of moons. We'll talk about those in a little bit. Saturn, unlike all the other planets, has its overall density is less than that of liquid water. And this is the thing that I always point out. Now, you can't do this, of course, but if you had a bathtub and the bathtub was big enough, you could float Saturn in a bathtub, right? Because it's less dense than water. But of course, that's silly because Saturn is this immense planet, and you can't really do that. But it's interesting to think about. All right, let's see. So of course we have the rings, which are this this icy material. Whether it was a moon or not um, is still in question. I mean, it could just be ice. Multiple icy bodies that got too close to Saturn and got torn apart. Like a comet, for example. It could be cometary material. All right. Anyhow, the inner part of the rings rotate faster than the outer part. So this is the inner part of the ring, the outer part of the ring. But that's just due to gravity. Um, let's see, the rocks that make up the ring orbit independently of other rocks. So it doesn't orbit as a solid object. Um, in fact, there's these little moons, tiny little moons, that are more dense than the ice, of course, and they're called shepherd moons that kind of keep the rings in place. If the rings get a little too far or too close, the moons, the tidal force, or sorry, the gravitational forces of the moon will keep the rings in place. Now, we don't think that the rings are a permanent feature of Saturn. That perhaps they're maybe 100 million years old or something like that. In the grand scheme of things, the age of the solar system is 5.5 billion years. So this particular ring system that we're able to see is it's quite enjoyable to look at. It's one of the favorite planets for people to look at because it has other features besides just looking at this ball of stuff. When you look at Venus, for example, you can tell it's a planet when you look through a telescope or binoculars, but there's no features on it, right? Because it's very cloudy. And when you look at Saturn, of course, if you have a small telescope or a pair of binoculars, you can easily see the rings. All right. So anyhow, what else? Saturn has one large moon and numerous, dozens and dozens and dozens of small, tiny moons. All right, so let's talk a little bit about this large moon. It's called Titan, and so Titan was of great interest, is still of great interest to us because it has there's several features that it has. One is that it has a nitrogen-rich atmosphere, which should sound very familiar to you because, of course, the Earth has a nitrogen-rich atmosphere. We think that Titan's atmosphere is very similar to the early Earth, and we've actually landed a spacecraft on Titan, the Cassini spacecraft, which orbited. Remember, Cassini here. If we go back to this, Cassini was the astronomer who first named this gap. And of course, hundreds of years later, we sent a spacecraft that orbited Saturn and it orbited well over a decade. In fact, it might have been about 20 years. I'd have to look that up. But the Cassini spacecraft orbited Saturn for many, many, many years. And of course, one of the things that it did is it had, so let's get back to Titan. It had a probe. The Cassini spacecraft had a probe on it called the Huygens probe. And the Huygens probe, very, very early, I think this was in 1995 or so, the Huygens probe was released by the Cassini spacecraft and parachuted into Titan and landed. And in fact, these are some pictures. As it got closer and closer to the surface. Here on the far right hand side, you can see some rocks on the surface. One of the other features. Let's see. Is that? Oh yeah, they're going to move on. One of the other features that we found on Titan, which is completely unique, is we found lakes, gigantic lakes on the surface of Titan. Now, it's too cold for the lakes to be water. It's not water because water is completely frozen at the temperatures of Saturn and Titan. The lakes are actually made of methane and ethane. So that is something that is very, very interesting. And there's one other moon. So there's a bunch of moons. Not obviously they're mostly tiny moons. But there's another one called Enceladus. And Enceladus is of interest to us because it has a liquid ocean underneath the surface. It's got a frozen surface, but there's cracks in the southern hemisphere of Enceladus, and it spews out these geysers, these saltwater geysers, and this Cassini spacecraft actually passed through the saltwater geysers and measured the salinity of the salt of the water, and of course it turns out to be very similar to the Earth's oceans, and which of course leads to the question, just like the question that we have about Jupiter's moon Europa, does Enceladus have life under even microbial life underneath the frozen surface? And of course, perhaps someday we'll send a spacecraft to investigate that. And there's already some people planning that, but it's very expensive to send spacecraft. Um, but hopefully we'll get around to that. All right. Now moving on to the what are called the ice giants. So here's Uranus. Uranus is it's kind of a greenish blue planet. It's pretty much featureless. This is using enhanced optics, or it's really false color. What you're actually seeing in this picture, it's just plain blue, bluish green when you look at it through a telescope. Uranus is the first planet that was actually discovered with a telescope. It was discovered by a guy named Herschel. I think it was in 17. It was in the late seven. I think it was around 1781. But you don't quote me on that exact number. You can just type in Google, and into Google you can find out when William Herschel discovered Uranus. At any rate, he discovered this, and in fact, very shortly after he discovered it, within just a couple of decades, people realized that the motion of Uranus was not exactly according to Newton's law of gravitation, and so Uranus was not where it was supposed to be if you follow Newton's law of gravitation. And so people realized, hey, there was something else out there, causing the orbit of Uranus to be slightly different than we expected it to be. And of course, that was Neptune. Neptune was discovered in the early 1800s, yeah, I'll talk about that in just a second. All right, so Uranus is about 4 times the size of the Earth, and it's really an odd planet. It is so you know how Earth is. Earth is tilted by about 23.5 degrees with respect to the sun. So that, of course, gives us our seasons. Mars is tilted by about 24 degrees, and so forth. Uranus is actually somehow tilted on its side. It's tilted by more than 90 degrees, so close to 98 degrees, and that means that the North Pole of Uranus, for half of its orbit, for roughly 44 years, will face the sun, and then the South Pole is in darkness, and then the other half of a Uranian year, which is roughly 88 years. In other words, it takes 88 years or so for Uranus to go all the way around the sun. Then the South Pole is in sunlight, and so the equator doesn't really get very much sun at all, which is really strange. And there's something caused this to happen. The big theory that the current theory anyway that we have about why Uranus is tilted on its side like this is that there was a collision. A collision caused this. It does have a ring system around the planet. It does have it has moons. It's very cold. Yeah, I mean, there's only been one spacecraft that has ever visited Uranus. That is the Voyager 2 spacecraft, which was launched in 1977. It passed, Saturn. It passed Jupiter and Saturn, and then Voyager 2 made it past. It just passed by. It was, less than a day that it passed by. Took lots and lots of pictures, and pretty much gave us most of our information about Uranus and also Neptune. So the Voyager 2 spacecraft passed by Uranus in 1986. All right. Neptune, of course, is beyond. It's about about 4 times the size of Earth. It's a little bit smaller. They're